Hey everyone, good afternoon, good morning, good evening, wherever you're joining in from today. Welcome to another live session at the Reactor. Um, Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, ask a lot of good questions. The chat will be open throughout, and we do encourage you all to participate. So we're back with another episode of the .NET Innovate Modern Cloud Solutions series. Today we'll be talking all about .NET microservices in Azure Container Apps. And with that, I'm now going to bring Ryan up on the stage, and he will take it from there.
Hello, everyone. Yeah, thanks, Rob, for the introduction. And yeah, my today's topic is all about that microservices using or with Azure Container Apps. And without further ado, let's just continue. Okay, so before I go discussing about Azure Container Apps, I should yeah, I should show this what is serverless. So basically, serverless. When you say serverless, it doesn't mean there's no server at all. Just for the sake of others who don't know about serverless yet, it's just this is it's like you don't need to think of underlying infrastructure. You just can focus on the on your task or on the programming task that you have. You just need to deploy your project, and that's it. Oh well, the scaling also is automatic. It is built in, and you can also usually you have an option to set your scaling rules. But yes, in serverless, it's scaling is automatic. The last box here, which says more efficient use of resources, because this box will support uh, with my next slide. It's all about the cost that you are using about your services. So in this comparison, in serverless computing versus traditional computing, um, in my example, on my left side, I am, let's say, for example, I'm using Azure Function here. So the way I am being billed or being charged for the service that I'm using is I will be charged for how long this backend service API is running or being executed. So, and in this example, I will only be charged for 100 milliseconds. And if I compare this to traditional computing, I will be charged for this backend service API, disregard if this is running or if this is being really used or being executed, as long as the server, or in this example, app service, is well, app service is running. I will be charged for the uptime 72 hours for this one. So it's really cost efficient if we check this comparison. But of course, it this will depends on the requirements that you have in your real project. And yeah, another just to give another information about me for the sake of others who don't know me yet, you can just check my LinkedIn profile for my background, a professional background, and I also have this YouTube channel. You can subscribe there. And currently, I am a Microsoft MVP in the category of Azure Cloud Native. Yeah. Okay, so since I have already discussed a little bit about serverless, and I'm sure there are lots of information about that. And yeah, so what is Azure Container Apps? This is basically it is built on top of open source foundation. It's built on top of Kubernetes or Kuber. I don't know how to pronounce that really well, but yeah. So if maybe if you are a kind of developer who really hates YAML files or some kind of complex configuration, you can just use Azure Container Apps, and you can easily see the what do you call this, how easy it is to work with this when it comes to containerization of your application. ACA, or Container Apps, still uses K8s. It's like Container Apps is just abstracting the Kubernetes. All of the functionality of that is still exists, or you can do what you are doing inside Kubernetes environment. And of course, Container Apps has more limitations than KS, because it is just abstracting this, and by saying that it's like, if you have this complex scenario uh, where um, where you need to communicate with different K8 APIs, like controller plain APIs or cloud API to connect to cloud environment. You cannot, of course, you cannot do that. ACA, or Container Apps, has this two plans. So if you want to work with like a pay as you go, or a serverless capability, you can just choose this consumption plan. And the other one is dedicated plan. If you have more complex requirements, like if you want to define different workloads or hardware specifications for your services, you can choose this. So what types of applications can you build using Azure Container Apps? Um, like what I have mentioned, you can work with microservices. So, and um, this is being the scaling criteria for this one is in microservices. This will be scaled based on the events and communication of your microservices. You can also have an API endpoints, a basic API endpoints. You can also work with that, as well as web application. A normal web application can also you can also work with that kind of applications, and that will be scaled based on the HTTP request or load of those API endpoint and web apps. You can also work with event-driven processing, and if you have different, let's say, for example, RabbitMQ, if you're working with that, you can also take advantage of Azure Container Apps, and that will be scaled based on the messages in the queue. So if you have zero message inside your message queue, you will well, the container app supports the zero scale. So it means if this is not if there's no in this event driven processing, if there's no messages inside that, you that will be scaled down automatically, and you will not be charged for that one. The background processing, you can also work with this Azure Container Apps. If you have this old tradition background processing, you can also work with this one, and that will be charged based on the memory loads of that processes. For the high level infrastructure or structure of Azure Container Apps, it goes something like this. It's a little bit messy, but I tried uh, to split this into pieces. So basically, in Azure, Container Apps lives in one container environment, and they are sharing the same virtual network. This is like this environment holds your different app container apps, which is equivalent to your microservices. So as I have mentioned, you can have multiple container apps inside container apps environment. So you have to have this environment to for your container apps to communicate with each other. And we did and these container apps represent your microservices. You can have multiple microservices inside this environment. In this environment, container apps environment, you can set different observabilities, or you can monitor, or you can set your loggings for all of your container apps. You can set that. And within container apps, you will have you can have multiple revisions. So a normal case for this, for having multiple revisions, if you want to, if you have this blue and green deployment, that is also supported when working with container apps. And they say, for example, you have a new version of your container apps, you can split different revisions for that one until, let's say, until this revision 2 is fully tested. And within this revision, you can have multiple replicas. So this will depend on how you set your scaling rules. So you can set your replicas for, let's say, for example, you can set a 10 replicas as default, but typically you will only have one replica. But yeah, this is still supported. And this is also automatic based on the load or the demands of your service. Or let's say, for example, it needs to have it needs to have multiple or more replicas inside this revision. It depends on the scaling rules also. I will try to show you that later on my demo. And finally, inside this replica, you will have your containers. So it's either it will be your backend API or your front end. You can have that, but like what you can do for revision and replica, you can have multiple containers inside this. Or the common scenario for this one is like if you have this sidecar containers, like for example, you have this side containers which is responsible for logging different informations about your main containers. Or if you are working with state management, you can also have that as a side container. Okay, so I just copied this diagram. Actually, this is a good example solution architecture when we're for Azure Container Apps. And as you can see here, you have this front end which uses Docker service identification to communicate with the backend API, and this backend API is just tapping this backend processor. So this is just a straightforward example. So you can have, like what I have said, you can set a different application insights and log analytics for different services that you have here. And of course, Azure Container Registry is also here for building your container images. And yeah, so the next question is, how do you start working with container apps? So you can work with Azure CLI, or you can also create Azure Container Apps directly inside Azure portal, and I will try to show you that later also. But typically, you will work with this command line. So of course, you have to log into your Azure subscription, and these are the common Azure CLI commands that you might want to do or execute. Once you have your projects ready, so here are the different um, what do you call this, commands to deploy your project. So in this first example, so if you have an existing image, you can just trigger this, get your image source. You can just get the URL here, then yeah, then execute this one. or if you are working locally, if you have local projects, you can also try to just trigger this AC container app, then then define different resource group and your source directory in your local machine. And lastly, you can also work with GitHub repository. You just need to supply or to give GitHub repository URL here, and yeah, it will do the magic for you. It will deploy, and you can also work with. Actually, I will use this instead of Azure standard CLI commands. I will use this Azure Developer CLI. This is a new tool for deploying your projects to Azure portal. You can check the website about this. You can just install that by using PowerShell command, and you can, yeah, after installing that, you can do different this AZD command. Usually you will work with this basic, or well, I can say most common command of AZD, but there are lots of things that you can execute using Azure Developer CLI. Okay, so that was for my slide presentation. So I will go directly um, to my demo. So to give you more insights about this. So in here, I have a I'm sorry, a basic .NET application. I just created this earlier. So let me just run this real quick. So this is just a basic weather forecast backend API. Let me just run that just to make sure. Forecast. So nothing special here. So if we go back to the command that we are going to use is like what I have mentioned. I will use this Azure Developer CLI. Let me just log in to um, my description. I will be redirected to this. Okay, and that's it. Okay, I will also need to let me just open this project. Okay, let me just make this big. Okay, so the first thing that I need to do is ACD init or initialization. This command will ask me or um, will ask me if I will use this local directory as the source of the project, or if you let me just no, I cannot show it anymore. But there are lots of ACD template that you can work that you can play around, and I will show you that later. So yeah, this ACD command detected that there is a .NET project. You can just confirm that, and let me make this 80 and environment name. This is well, the environment name that I will supply here will be used as the name of Azure, as the name of resource group inside my Azure subscription. So let me just try to react for Ryan. Okay, so as you have noticed, this command generated different files and folders here. The first file is this next steps, where you can check the different options that you have when if you want to deploy your project. So if you have this CI/CD pipeline inside your GitHub or Azure DevOps, you can just follow different instruction here. And there's also some um, some example command here. Yeah, you can just follow this. You can just follow the instruction written here. And the other file that you have that has been generated for us or for me is this that Azure folder, which has the environment variables. As of the moment, there's no this is the only content of this file. But once I trigger the the dex command, it will populate different environment variables here. And the other file that I have here is this infra folder, which has all the biceps files that which will be used to deploy and provision and deploy this .NET project. And if we can just open this, this is just the straightforward bicep um, declarations that you will use. Okay, let's try to deploy this now. CD. Since everything is here, all I have to do is just to trigger this AZD app. I will use my free subscription. I will use this US, and of course, because my Docker is not yet running, I should run that first. Okay, let's try to run this again. AZD up. Okay, so I will not wait for this to be finished because I have already deployed something earlier before I start this session, before I start talking here. So and let me just open the finish deployment here. Okay. So what will once I have the deployment, I will have once this deployment is finished, I the that that command will generate the resource group, which is, I think the name that I use is Reactor Ryan, and that will have the container apps environment and the app service, and that's it. And that should look like, well, actually, this is the front end side. Front end application, the Blaze. Oh, sorry, I mean the API service. Yes, I was wrong. So I cannot access this because I set this API or service as a private API. But I can make that publicly accessible by just going to Ingress, and I can just choose this accepting traffic from anywhere. Then let's try to save that. Let's just wait a little bit. This should be this should not take too long. Okay, and let's try to open this again. Okay, and weather forecast. Okay. Yeah. So as you remember, the local project that I just tried to run earlier. So this is the same as the one that I have shown you. So, but if you have well, typically if you have this microservice project, you only have one public project publicly accessible project, which is your front end. And in this example or sample resource group services, I only have this um, front end, which is a Blazor app which communicates to that API, the one that I have shown. But still, you can if you have an internal setup inside your company, you can also hide this publicly. You can just set different IP addresses that can access this um, web front end. Okay, so maybe someone will ask how can I create that inside Azure, that Azure Container Apps. You can also just create that service. Just go to here and find that Azure Container Apps. Container Apps, Container Apps. This one, just click Create. I'm not sure if this is visible. I will, okay, I will just change my subscription and I will choose this reactor and I will name this test service. Okay, container image. Yeah. Okay. So if you already have a container Azure Container Registry image, you can use that, or you can also work with your own Docker Hub. You can just point that this container apps to that Docker Hub or any container registration. But in this example, I will just use this default template, which has a like a welcome page or welcome HTML file, and this should be it. Let's just create this. Create. Okay. Okay, while we are waiting for that, let's check. Okay, still uploading. This should take 2 to 3 minutes. Okay, let's go to that resource and let's try to run. Yeah, so this is just a default template, but you can override this, of course, with your real project. And let's just check different blades or menus here. So as I have shown you earlier in my slide presentation, you can have multiple revisions and replicas based on your requirements. So here you can set replicas and revision by just well, for revision first. By default, it's set to single, but you can change this to multiple, so you can have multiple revisions. Once you have multiple revisions, you can set the traffic. So you can, let's say, for example, your first revision will receive 100% of your traffic, and 60% of your traffic, and your other revisions will have a low 60, then 40% traffic. So you can do that, and for the scaling part, you can set different scale rules here. Um, you can uh, you can just do this scale. You can set your scale rules depending on your requirements. So, but this is not the one that I want to show. But yeah, you can have this custom here where you can choose different scaling rules. You can define what you need here. It's very flexible. It's up to you how you use this. Yeah, you can just explore this later on. Okay. And you can also have this authentication enabled. Or I mean, if you have any other identity provider, you can also set, or you can also add that here. If you are working with Facebook or Google identity provider, you can just add that here. For secrets, you can also add different secrets here for your. Well, it's a best practice to use this secrets here to add secrets for your different environment variables. Ingress is like what I have shown you earlier. This is the setting where you can hide your different container apps. You can just set that here. Even the port, you can manage that here. For deployment, you can take advantages of this setting page. You can also set different configuration here. If you want to work with your own Docker Hub, you can. If you want to work with your GitHub workflow or GitHub action, you can also set that here. Azure Container Apps fully supported Dapper or DAPR. If you are not familiar with this one, this is a really good uh, tool for when working with microservices. You can read this Dapper. Uh, Basically, this is the sidecar sidecar service that you can integrate within your microservices project. You can just yeah, you can read this later after my session if you want. If you're not familiar with this, this is a good uh, tool or framework that you can use. I have used this before, and as a matter of fact, I have a sample Azure Container Apps projects which uses this Dapper. I will show you that later. The other menus here is a self-explanatory. Well, you can also have this. You can also work with managed identity if you are familiar with this. So instead of having different connection string or connection information inside your project, you can just use this. You can just take advantage of this managed identity capability of Azure Container Apps. And the other menus or items here is it's just a normal menu where you can usually encounter when working with Azure. Okay, so like what I have mentioned, I also have other project here, which has Dapper. enabled service. So let me just run this. Just run this, and the other one. Oh, sorry. The other one. Check out processes. Right? Okay. Okay. To to make sure that this is working, this should logs. I need to refresh. Let me open the local project for that one first. Um, ACA Docker. Okay, so what does those project is do are doing is, yeah, it just sending different information asynchronously. So um, check out basically sends um, message to order processor, and that's just a looping, and it's just um, writing some logs. I think that's already running. I'm just buying time for that one. Okay, so let me just run. Yeah, so this message is directly coming from, let me just open another tab, from the checkouts service. Let me just open that simultaneously. Check out. Okay, so this is sending or logging or writing the same logs as the container apps order processor. So to confirm that, let me just stop this. Stop. Okay, and they should stop receiving something, which is also happening. Let's try to run it again to make sure. And this should resume after. Yeah, so it resume receiving something again because I just restarted the checkout service. Um, I did not created this project. Uh, what I did is I just pulled that from. If you are familiar with Azure Developer CLI templates, you can explore that um, by just doing this as ACD template list. Sorry, adding list. You can get different project here, and what I have used is the container apps. Yeah, there's a container apps here, container app project here. Let me just close that. So there are lots of templates that you can play around here. And actually, I also have my own my own template here. This one, if you want to work with serverless template, you can also check that. And you can also go directly to this URL where you can check different templates. So, like what I have mentioned, I use this template, the Dapper template, this one. So I just use this for my demo. Just copy this and paste it in your terminal. And like what I have mentioned, I have my own template here. If you are interested, you can just play around with my own template. What else do I need to show? Okay, so I think that's all for my demo, and I am opening for the question and answer part of this session. And thank you for listening.
Thanks, Ryan. So we have two questions. Is it possible? Well, one is it possible through PowerShell?
Yes, yeah, everything, yeah, it is possible, 100%.
And what is the bicep file for?
Well, Bicep is for, well, if you're familiar with infrastructure as a code. So Bicep is, let's say, if you're it is a let me put this way, it's a counterpart of Terraform. If you're familiar for Terraform, it uses for deploying your projects for your, yeah, for your automation. You can also use that. You can have multiple Bicep.
In what case would we want multiple replicas versus multiple containers?
Well, the replica will be based on the workload of your container app. So let's say, for example, um, different requests coming from different client, uh, well, multiple requests from clients for your container apps. It will be much more efficient to have multiple replicas to handle those requests to make sure the performance of your service is will still be okay. And for containers, well, the containers is like you will have one container for your backend API or your and one container for your front end web application. So, or another container for your asynchronous background processing. Let me just show this example example diagram. So as I have mentioned, for containers, you can have multiple containers like this. You will have your front end as one of your container, your back end as one of your container also, and back end processor for another container. And if you want to make sure that this, let's say, this backend API can handle different loads or requests, or let's say, for example, million requests per hour, I'm sure you need to add different replicas for that one. For yeah, yeah, I hope I answered that question.
Thanks, Ryan. So another question: Dapper used. So what what was the
Well,
purpose of Dapper? So Dapper.
well, Dapper is a sidecar service that you can use, or side components that you can use. And let's say in this, Dapper has multiple components, building blocks. They call this building blocks. So if you want if you want to work with publish and subscribe, service to service, what I have shown in my demo, I just use this service to service invocation. But you can also use different, like, state management for making sure your the state of your applications, like this main service that you have can independently have multiple dependency. Like, let's say for example, this state management uses redis. So if you want to change that redis, you don't need to modify or update your main container apps or service. You just need to change this or remove this and use another state management tool. So it's like a sidecar. It's like this is your main service, and your service has this sidecar. It's like your dependency, which is very handy if you just remove this, and your application or your main service will still work. So yeah, you can also check this different components. There are lots of different components that you can work with this one. As you can see here, so this is what I am trying to explain. You will have your service or your app, and this app has this Docker. And this Docker can communicate to these different components or different tools or different service that you can use for this service or app. So let's say, for example, like what I have mentioned, if you want to work with Redis for your as your state management, you can also do that. Or if you want to use I cannot what is the other state management database, you can also change that. It depends on your preference. But here, so yeah, it's your sidecar service. Let me put that way. So Dapper is like your sidecar service for your main service, which is very flexible.
Um, so Ben, who asked the question about the multiple replicas and multiple containers, asks, they say it was on slide 4, but you had multiple containers within a replica for one container app. Which is the bit I didn't understand?
Okay, let me just go back. Which one here? This one? This one?
It's probably maybe, yeah,
Yeah.
this the one on the
Okay.
slide 4.
So as you can see here, so the replica is all about handling different loads or different workloads of your service. So you can typically you will only have one replica. So if you are being confused about this one, but you typically you can have you will have one replica. But let's say for example, you have multiple requests for this. Let's say this container app is your public backend API, and this one replica alone can handle those requests. You should well the main solution for that one is to have multiple replicas, so that the request will be distributed between different replicas or amongst different replicas to make sure the performance of your service will still be okay, even if there's a high volume of request. And if we yeah, so I think that's a explanation for that one. But like what I have mentioned, a normal or a standard number of replica is only one, based on depending on how depending on the volume, or yeah, the volume of number of requests that your service will handle. I hope I answered that well.
Okay, well, thanks, Ryan. I think those were all the questions. So yeah, thank you very much, and we will see you. I think in 2 weeks' time we have two more sessions added,
Hmm.
and we'll see you. Yep, and I've put the links in the chats for the two new sessions which have been added, and we'll see you if you register on. We'll see you then. Brilliant. Well, Thanks very much. Thanks, Ryan. Thanks, everyone, for joining. Have a good rest of the day.
Thank you. Bye.